Welcome back, students. This is the session 1 from the playlist of assertion and reasoning. The chapter is electric charges and fields, and this is the session number 1. So, I will be covering approximately 20 to 25 questions based on this assertion and reasoning type of questions. And the chapter, this is the first chapter from the syllabus of class 12. So here I have taken one question in which the assertion is given and this reasoning is also given. Now what is assertion? Assertion is basically a statement in which we strongly believe in, and this is the reason which is the explanation for this assertion. So based on this assertion and reasoning, there are 4 options given in this question. So normally these are the 4 types of options which is normally available in the question paper, and these type of questions are basically asked in the board examination. So the first option here is both the assertion and this reasoning are correct, but this reasoning is not the correct explanation of this assertion. In the second option, B, both A and R, that is assertion and this reasoning are correct, but reasoning is not the correct explanation of A. In the C option, this assertion is true, but the reasoning is false. And in the fourth option, the assertion is false and the reasoning is true. So this is the first session from the chapter of electric charges and field. I will be trying to cover up near about 25 questions, which will in such a way that all the topics pertaining to these chapters are covered. So this, in the first session, I have taken this question which is written on this board. So in a non-uniform electric field, a dipole will have the translatory and the rotational motion. Second, this is the assertion, and the reasoning is that in a non-uniform electric field, a dipole experiences a force as well as a torque. So let us try to understand this with the help of one diagram. So here I am just trying to, I will be making one diagram here. Let us see this is. Now this is the direction of the electric field, and this is a dipole which is placed in this external electric field as shown in this figure. So this is a negative charge and this is a positive. So what is a dipole? So dipole is basically, it is a combination of equal and opposite charges, and they are separated by a very small distance. Now this is a positive charge here, so the force which will be acting on this charge will be along the direction of the electric field, and the force on this negative charge will be opposite to the direction of the electric field. So in the case of a uniform electric field, let us say this is a dipole which is making an angle theta with the direction of this electric field. So when the electric field is uniform, then these two forces which are acting on the positive and the negative charges, they will produce a torque, and it will try to rotate this dipole so that it gets aligned with the direction of the electric field. So the torque is given by P is sine theta, where P is the magnitude of the dipole moment, E is the magnitude of this external field, and theta is the angle made by this dipole moment with the direction of the electric field. But in the case of, so we can say that in the case of this uniform electric field, this dipole will experience a torque. But in the case of a non-uniform electric field, what will happen, that this charge this is a positive charge Q and this is a negative charge Q. So both these two charges will not be experiencing equal forces. Okay? So as a result of it, what will happen, that this dipole will experience a net force. The dipole will experience a net force. because in the case of a non-uniform electric field, because the force on, let us say, this positive charge and the force on this negative charge will not be equal, and because of that a net force will be acting on the dipole, and this net force will produce an acceleration in this dipole, and because of that acceleration this dipole will have this translatory motion. In the case of a non-uniform electrical field, this dipole will be experiencing a net force, and because of that net force this dipole will have it will have some acceleration, and because of that acceleration it will get a translatory motion, and at the same time this dipole will also experience a torque which will try to align this dipole along the direction of the electric field. So in this case the assertion is correct, the reasoning is also correct, and this reasoning is the correct explanation for the assertion, that is for this assertion. So the correct option will be A. So I hope you have understood the solution of this question, and the most important thing here is that in the case of a non-uniform electric field, the dipole experiences a net force which produces a translatory motion, and because these two forces are acting in the opposite direction as indicated by this arrow, so it will also produce a torque. So thank you very much for joining this session. In the next session I will be coming up with a different type of a question, but the chapter will remain the same, that is electric charges and field. So till then, have a nice day. Bye.